Welcome, travelers of the cosmos. Today we embark on a journey towards the colossus of our space neighborhood, Jupiter, the king of the planets, the guardian who keeps our solar system in order, but also a giant full of mysteries, electrifying and otherworldly storms. Jupiter is not only the largest planet in our solar system, it is also a symbol of power and magnificence, a floating enigma that we are still trying to decipher. What secrets lie beneath its turbulent clouds and indomitable atmosphere? Stay. Because what we're about to discover will change the way you see space forever. Imagine a place where storms never cease, where lightning can be 1,000 times more powerful than those on Earth, and where the atmosphere is a veritable battlefield of titanic forces. Jupiter is a planet of extremes, and today we are going to unravel some of its greatest mysteries. Now imagine that we are in a future era, where technology allows us to explore Jupiter up close. Imagine a manned mission descending through its atmosphere. The astronauts would find themselves facing winds that would exceed the most extreme speeds recorded on any planet, while the ship would struggle to remain stable in the midst of a raging storm. Jupiter's atmosphere is a true wild jungle of chemical elements in constant motion, from the predominant hydrogen and helium to traces of ammonia and methane, creating colors and textures that would make anyone wonder and terrified at the same time. As we delve into this gas giant, we can begin to perceive how its atmosphere changes as we descend a few hundred kilometers below the clouds above. The pressure becomes so intense that the gas begins to transform into liquid. This sea of liquid hydrogen extends for thousands of kilometers, and its weight presses the lower layers until they transform them into metallic hydrogen. It is this strange substance that generates Jupiter's colossal magnetic field, the most powerful in the solar system. It is difficult to imagine the amount of energy flowing here as an invisible sea of magnetic forces that affects not only the Jovian moons, but has a much greater scope. A true giant that dominates its environment. However, the journey does not stop there. If we continue descending, we enter a realm where temperature and pressure become so extreme that the elements behave in unexpected ways. Metallic hydrogen becomes a conductive fluid that generates electric currents, feeding Jupiter's immense magnetic field. This inner sea of metallic hydrogen is perhaps the most enigmatic feature of the planet. Imagine a surfaceless ocean, a liquid that defies our understanding, existing only under the most extreme conditions. Can we imagine? Jupiter is a world that constantly reminds us how little we know about the physics of gas giants and talking about Jovian moons. Every one of them is a unique and fascinating world in its own right. Now imagine Callisto, one of Jupiter's outer moons. This satellite is full of craters, a real-time capsule of the solar system. Callisto is one of the oldest and least altered surfaces we can observe, giving us invaluable information about the beginnings of the solar system. But Callisto isn't just a cratered moon. Beneath its surface there could be an underground ocean. This ocean, protected by a thick crust of ice, is another place where scientists believe hidden life could exist in the depths, where the satellite's internal heat could create habitable environments. And if we look towards Ganymede, we find not only the largest moon, but also the only one with its own magnetic field. Ganymede has an ice-covered surface with dark and bright regions that reveal a complex history of geological activity. What secrets does its core hold that allows the generation of this magnetism? The complexity of Jupiter lies not only in its atmosphere and size, but also in the richness of its moons, each of which could be studied for decades. Ganymede could harbor an ocean beneath its crust similar to that of Europa, which adds another mystery to solve. Could there be hidden ecosystems beneath its ice? Then we have Accent there, whose volcanic activity is unmatched in any other body in the solar system. Its constant eruptions spew sulfur, which paints the surface yellow, orange and red. And with an accent, it is a visual spectacle, a ballet of unleashed geological forces that defies the imagination that drives this constant activity. It's the gravitational force of Jupiter and its neighboring moons like Europa and Ganymede, which stretch and compress there with emphasis, generating the internal heat that fuels these volcanoes. This interaction between moons and the giant planet is a perfect example of how tidal forces shape the environment in the solar system, creating extraordinary and dynamic landscapes. In Nikon Ascento we can see how gravity becomes the engine of geology, creating a constantly moving hell that, although hostile, is wonderfully spectacular. Jupiter is also home to the phenomenon known as the Jovian auroras. Similar to Earth's auroras, but infinitely more powerful, these lights shine at the gas giant's poles due to charged particles trapped in its magnetic field. These auroras are not only beautiful, but also the signal of the intense electromagnetic interactions that occur on the planet. Even beyond the atmosphere, Jupiter presents itself as a titan. With their influence felt millions of miles away, Jupiter's auroras are powered by both the solar wind and material ejected from Icon Ascento, an example of how the interaction between the planet and its moons creates a visual spectacle unparalleled in the solar system. Jupiter also has other surprising weather phenomena, such as its polar cyclones. At Jupiter's poles, the Juno probe has discovered cyclonic structures arranged in geometric patterns that challenge our understanding of atmospheric dynamics. These cyclones remain stable for years, creating a kind of constantly rotating beehive, a view that seems taken out of a work of science fiction. The stability and symmetry of these cyclones are a mystery that scientists are trying to decipher, since they are unlike anything seen on other planets in the solar system. And speaking of the Jovian moons, every one of them is a unique and fascinating world in its own right. Now imagine Callisto, one of Jupiter's outer moons. This satellite is full of craters, a real-time capsule of the solar system. Callisto is one of the oldest and least altered surfaces we can observe, giving us invaluable information about the beginnings of the solar system. Even beyond the atmosphere, Jupiter presents itself as a titan, with its influence felt millions of miles away. One of the most intriguing questions about Jupiter is, how did this giant form? Scientists believe it was the first planet to form around our young sun, accumulating gas and material until it became the titan we know. However, the exact process of giant planet formation is still a field of debate, and Jupiter could be the key to solving that enigma by understanding how Jupiter gathered so much mass and why it became a gas giant instead of a rocky planet. We can get a better understanding of how other giant planets formed in distant solar systems. In addition, there is a fascinating possibility: future missions to Jupiter and its moons could help us find signs of extraterrestrial life. The water vapor plumes of Europa, the volcanic activity of Icon-Ascento, the oceans under the surface of Ganymede. All these places have conditions that could, in one way or another, allow the existence of life forms. Maybe they're not advanced creatures, but even the discovery of microorganisms would be an event that would completely change our perspective of the universe and our place in it. We could one day send a probe to drill into Europa's icy crust to look for life in its subterranean oceans. The mere idea of what we might find is reason enough to dream and explore. Jupiter is not only a guardian for Earth, it is also a constant source of inspiration and questions. Its great red spot may one day disappear, but its smaller, more dynamic storms will keep spinning, giving us new clues as to how these phenomena work. In addition, its gravitational influence plays an essential role in maintaining the balance of the solar system, stabilizing the orbits of other planets, and protecting us from cosmic threats. If ever there was a colossus whose existence affected the fate of the Earth, that colossus is Jupiter. But we can't talk about Jupiter without mentioning how enigmatic its heart is. Scientists aren't sure exactly what's at the center of this giant. Some think it might have a solid core, while others believe that it is such an extreme place that matter behaves in ways we cannot yet understand. It is speculated that in Jupiter's core, there could be a mixture of heavy elements compressed to such an extent that they behave in ways that defy our physical laws. Perhaps in the heart of Jupiter lies a clue to the deepest secrets of the universe, a clue that allows us to understand how giant planets formed and what role they played in the formation of our own home. Another intriguing hypothesis suggests that Jupiter's core could be a dissolving core, where heavy materials gradually mix with the upper layers of the planet. This process challenges our understanding of planetary cores and the long-term stability of these gas giants. If this is true, then the heart of Jupiter is a kind of dynamic cauldron that changes over time, which could have implications for our understanding of the planetary evolution not only of Jupiter, but of all the gas giants. Jupiter is also a natural laboratory for studying extreme weather, the interaction of its atmosphere. Its magnetic field and its moons create phenomena like the Jovian aurora, which are hundreds of times more powerful than the aurora borealis on Earth. These dancing lights at Jupiter's poles are the result of charged particles interacting with its magnetic field, creating a visual spectacle that reminds us how small we are in the face of the immensity of the cosmos. Also, the winds on Jupiter reach unimaginable speeds, generating cyclones and storms that remain active for years, even centuries. These phenomena offer us a direct view of how energy can be stored and released on such a gigantic planet. So when you look up at the night sky, and you see that bright spot in the distance, remember you're looking at a real titan.